Hi guys, hello everyone. Today we'll talking about first order kinetics. So this first order kinetics is very important for JEE mains as well as the NEET exams. Simple questions will be asked but little twist in the question. So let us try how to solve these type of questions. Let us see what is first order, what are first order kinetics, what is rate constant, what is half-life period, and what are the different cases in it. Just we have to go through it. We also see few questions after this exam. Once we complete this lecture, you could able to do at least 2 questions from chemical kinetics. So let's begin the show here. So here is the first order kinetics. Let us say मेरे पास एक reactant है. So I am starting with the reactant is converting into product. So this reactant is converted into product. In this case, let us say the rate of the reaction is directly proportional to molar concentration of reactant power 1. So this one represents the order of the reaction. This is the order of the reaction. That's why we say it as a first order reaction. So let us derive the rate constant for the first order reaction. Then we'll go into the different cases. Okay. So for this case, the rate is going to be, so generally we write rate as change in concentration of R with respect to the time, that is minus dr by dt, which is directly proportional to this number. So that is R to the power minus 1. So just reorganize the terms here. So this is going to be dr over R equals to, I multiply both sides by negative, so minus, I'll take the proportionality constant, that is k, then goes dt. So this is the rate with respect to the R. Now we'll go for integration on both sides. We apply integration on both sides. When we apply integration on both sides, so what are we going to get here? The integration of dr by R is log R, which is equals to the integration of minus k dt. So minus kt plus, we'll take a constant of integration, that is I. So this is, let us say, equation 1. Now we'll go to, what do we do here? When time was 0, the reaction is not yet started. So therefore the concentration of reactants is shown by R0. So just I plug in these values in the above equation so that I'll get something about for I. So it is going to be ln R0 equals to, so this is, t is 0. So minus kt becomes 0. Minus kt becomes 0. Therefore I becomes equals to this one. So this is equals to I, isn't it? So this is equals to I, this is equation 2. Just I plug in this I value, the equation 1, to get the final reaction. So here is ln R, which is equals to minus kt plus ln R0. So this is the first order rate equation. Okay. So this equation is in the form of y equals to mx plus c. So therefore we can obtain a simple graph for this. So the graph is gonna be, so this is the y-axis, this is the x-axis. Okay, on y-axis I have to take ln R, this is the y-axis. On x-axis minus kt low, the variable is t. So I have to take the time on the x-axis, and the slope is going to be, negative slope, right? So the slope is equals to minus k, and the intersection here, it is called as ln R0. So this is the first order rate constant. Okay, so just we reorganize the reaction. So this one, just we reorganize it like this: ln R equals to minus kt plus ln R0. So I'll bring this to the other side. So minus kt equals to ln R by R0. So if I multiply by negative sign on both sides, I'll get ln r. So I'll be getting ln r naught by r. Okay, so just I open this one. So k equals to 1 by t times ln r naught by r, and we know that ln r e base logged, which is equals to 2.303 log base 10. So if I substitute here, k equals to 2.303 over t multiplied by log base 10 over r naught by r. So this is the first order kinetic equation. Okay, so we use this to calculate the things here. If you observe this equation, there are 4 variables are there: k, t, r naught, r. Out of these 4, you will be given 3 and you have to solve for the remaining. That's it, nothing more than it. Okay, so let's see. Let us talk about t half. T 1 by 2, yeah, half-life period of the first order reaction. This is also another important case here. So half-life period means the time taken for r naught to become r naught by 2 is called as t half time. Initially आपने 100 ग्राम्स लिया है, 100 ग्राम्स में से 50% रिएक्ट होने में, सो 50 ग्राम्स होने में जो टाइम लगेगा वही होगा टी हाफ. 25 ग्राम्स होने में जो टाइम लगेगा वही टी हाफ है. 25 अगेन 12.5 होने में जो टाइम लगेगा वही t 1 by 2 है. Right? So we also do the numericals based on this way of doing it, but we'll substitute these values here. So we got k equals to 2.303 over t half to t. Just I'll replacing it. So I'll be getting log. So here is the r naught, and the final concentration is going to be r naught by 2. So this turns out to be k equals to 2.303 over t 1 by 2. So this turns out to be log 2, because r naught gets cancelled, 2 goes up, log 2. Log 2 we know it. Log 2 equals to how much? 2.303 by t 1 by 2 into 0.3010. Right? So if we multiply these two numbers, so k will be equals to 0.693 over t 1 by 2. This is the formula. Yeah, t 1 by 2 equals to 0.693 over k. Right? So we have to find the k and we have to substitute here. Just we have to divide 0.693 by k to get the t half. And one more point to be noticed here: t half of first order reaction, first order, is independent of concentration term. Independent of concentration term. You can also see this one. Why? Because this formula included no initial concentration term. This term is not there. That's why it cannot be dependent on the initial concentration. So what is the meaning here? If you have taken 1000 grams, जो 500 grams होने में जो टाइम लगेगा, फॉर एग्जाम्पल यहाँ 5 hours लग गए, 500 to 250 होने में भी 5 hours लगेगा, 250 से 125 होने में भी 5 hours लगेगा, 125 से भी आधा होने में, सो आधा कितना हो जाएगा, सो 62.5 होने में भी उतना ही टाइम लगेगा. दैट्स वाई इनिशियल कंसंट्रेशन कितना भी हो, इसके ऊपर कोई फर्क नहीं पड़ता है.